Hello and welcome back. I'm Dr. Swope, and again, we're going to continue our virtual lesson series on AP Psychology. I'm from Maryland. I teach at Northwest High School, and I got to say, let's go, Jags. So let's kind of go. We've got a lot of stuff to hit today in a little bit of time. So our lesson overview is going to be the experimental method. You remember yesterday we talked about other research methods. Today we're going to dig deep into the experimental methods, and we got a couple things to hit today. Um, Independent, dependent, and confounding variables. Okay, and control. What does that mean? And even though the presumption is you have had an AP Psych class most of the year and you've been introduced to this, these can be some tricky stuff, some tricky things. So we're going to go and explore them. We're also going to look at how, now this is a complicated way of saying a simple thing. Describe how research design drives the reasonable conclusions that can be drawn. It basically means good research can allow for good results. And that's, we want to look at what is a bad experiment, what can interfere with a good experimental design. Another thing that gets students a little bit mixed up is random selection versus random assignment. We're going to talk about that today. And the last two bullet points are about ethics. And how ethics guide and constrain research, and how we use these guidelines to protect animals and people. Let's look at where we left off yesterday in our good friend, Mrs. Schmidlap. If you remember that Mrs. Schmidlap wants to study whether homework actually helps her students learn, but she doesn't know the best way to study the issue. Given the three research methods below, explain how she might study her question. So again, our three things we talked about yesterday were survey, cross-section, and case study. What we're going to talk about today is experiment. And then, of course, yesterday we talked about operationally defining things. So hopefully you actually spent a couple minutes just trying to apply SOTAs to this quick question. And again, nobody wants to do an FRQ response, but a little bit of practice every day is going to really set you up for success on the AP exam. So let's look at the last three of SOTAs: define, apply, and synonyms. And so let's define a survey. I think you know what that is. It's a written or online questionnaire. So let's hope that you wrote or knew to write that. Then you're going to apply it. Mrs. Schmidlap can give her students a survey to fill out after they complete a homework assignment, asking them if it helped them learn. Okay, that might be a way to explore whether homework does help learning by just asking the students through a survey. If you just did define and apply, that might be okay, but we want to use the last S in SOTA, synonyms, which to go deeper. And you might want to restate it, demonstrate what you know. So you might want to say a survey might not be the best research method for this situation. While a survey might give Mrs. Schmidlap a lot of information, some of the survey questions might be confusing. And you remember we talked about that yesterday. And that means that her conclusions about homework might be wrong. So you're given the idea, you've defined it, you've applied it, and now you've shown some of the strengths and weaknesses of a particular research method. The next research method is cross-sectional study. Remember, actually, it's not a research method. It's just a way to frame and to do research methods. So we're going to look, we define what it is. It's not a research method. And then we say that Mrs. Schmidlap could compare the test results from her second period class, which didn't do homework for Unit 2, and her fourth period class, which did homework for Unit 2. Okay, so we've defined it and we've applied it. The cross-sectional study, now we're going to go deeper. The cross-sectional study is limited because it gives information at a certain moment in time. For instance, second period might not do a lot of homework on Unit 2, but they do homework on every other unit. A cross-sectional comparison would not include, remember yesterday we said it doesn't include a moving picture. So you want to go deeper, include a synonym or another way to say your main point. The next part of the FRQ from yesterday was naturalistic observation. And this is when researchers watch participants in their usual routine or familiar environment. So I think you know what it is. Now we're going to apply it. And here's a weird one. Mrs. Schmidlap could theoretically watch her students do homework to see if they were really doing it or merely copying it. One would hope your teachers aren't spying on you, but it is a possibility you could write in an FRQ response. And of course, we go deeper. Naturalistic observation might not be the best research method because Mrs. Schmidlap cannot see her students learn or process the information. And there we get into the operationalization of what does it actually mean to do homework? Or is it just copying and pasting? Is it mindlessly filling in blanks? Or is it thinking and learning and processing? So that was a couple ways you could have answered yesterday's FRQ exam practice. Let's look at where we're going today. And it starts with the independent variable. If we're going to talk experiments, we got to talk hypothesis, independent variable, and dependent variable. It might be worth noting that the independent variable is also called the treatment. And that doesn't necessarily mean in a medical or psychiatric situation where you give a pill as a treatment. It could be almost fertilizer. You give a plant independent variable, that would be the treatment. The best and most simplest way to remember this is if a hypothesis is a prediction, it's an if-then statement, okay? Then the I in if, so you got the if and the then. The I in the if matches with the independent variable. So I want you to always think if independent, then dependent. If independent, then dependent. But again, I think many of you have been exposed to this, so we're going to move on from that. We're going to use this example throughout our lesson today. If a person drinks coffee, then what? Okay. Do they feel more alert? Are they more jittery? Do they have a nauseated stomach because they drank too much? So if drink coffee, that's going to be our independent variable. Then what? That's going to be our result. I like to say that an independent variable is something the researcher does. Okay, it's something you give, it's a button you push, a lever you pull, something that hopefully will cause a result. It's important to note, and we're going to get into this later, this fourth bullet point right here, that the experimental group, sometimes known as the treatment group, they're the group that gets the independent variable. So if a certain group gets an independent variable, then a result happens. So hopefully that's enough review of independent variable. Now we're going to jump into dependent variable, also called the result. So if you give a treatment, you're going to get a result. If you give an independent variable, then you're going to get a dependent variable. The independent variable, like I said in the last slide, was what the researcher does. The dependent variable is what the researcher gets, or the result. And we hope it's a significant change from either the baseline or control group. Okay, what does that mean? Well, if I do a study and I say that coffee increases attention, okay, or increases alertness, the question is from what? A baseline is a starting point, and that's something that you've probably seen, but it's worth jotting down, or it's worth paying attention to. Again, your FRQ isn't about memorizing facts. It's can you weave these concepts together and apply them to demonstrate that you know what you're talking about in a deep and cogent manner? Or do we say, we hope it's a significant change from the control group? Is there a big or significant difference between the experimental group that got the independent variable and the control group that got a placebo or got nothing? So again, if you drink coffee, okay, that's our independent variable, then you will pay more attention to this video. So hopefully you have plenty of coffee around you. So I want everyone obviously to pay attention to this. But hopefully as soon as I said that, as soon as you read that, then your question, you're going to say, well, wait a minute, that's too simple. How do you operationalize pay more attention? Is it eye contact? Is it angle of the spine and how you're seated? Okay, those are things that if you're going to do a good experiment, you have to pay attention to what we talked about yesterday, and that's operationalization or operational definition. With dependent variable, the big question is the result we get what we think it is? And that brings up two errors we can get once we get our dependent variable. So if we spend days, weeks, or even years setting up this huge experiment, And we get our participants, we divide them into groups, and we'll talk about that later. And we give one group an independent variable and one group nothing or a placebo. And we wait and wait and wait, and then we measure them and we have a result. The question is our result worthwhile? Is our result true? Or is it what we call a type 1 error? And a type 1 error is when a researcher says, aha, eureka, my results are significant. But then they go back and look maybe a little bit more carefully. Maybe one of their colleagues says, no, the results, the dependent variable wasn't a significant change or difference. That's going to be called a false alarm error, where you thought there was something, but it wasn't there. Type 2 error is when you don't notice. And this can happen quite a bit with medicines. Imagine pharmaceutical companies do experiments, they do clinical trials, and they say, this drug is safe, it's great. And then they release it. And then they find out there are effects that they didn't notice, maybe side effects, or maybe the drug could be used in a way that they didn't originally think. That would be a type 2 error, where you don't notice the significant effect. Let's do a quick practice, because again, even students who study and study and study and they think they have a good handle on it sometimes get a little confused. So it's worth maybe slowing down a little bit. Let's look at Jimmy Schmidlap. See, Jimmy Schmidlap doesn't think that a temporary interruption of one of his high school years should throw off his whole academic goals and plans. He thinks that watching review videos and practicing FRQs will lead to a good score on the psychology exam. So pause for just a little bit. And can you identify the independent and dependent variable? Again, I'll give just a couple seconds of wait time. And hopefully you were able to say the independent variable is what he does, and that would be watching the videos and practicing FRQs, and the dependent variable would be a good score on the psychology exam. And that's kind of what I just said. Here's something I might add as an addendum to today's homework or practice, AP review practice. What I'd like you to do is, can you think of a scenario? Could you just jot something down? Nothing fancy, just a few couple of sentences. Can you think of a scenario that involves a hypothesis, an independent and a dependent variable? And I think that if you could kind of create one or two of these, then you're going to have a very firm grasp on it, rather than just passively doing other people's scenarios and questions. So that might be a good practice. Take a couple minutes and do that tonight. Okay, we threw a lot at you. We did independent variable, we did dependent variable, and we mentioned quite a bit of vocabulary in there. If you take nothing away from this, here's kind of a couple main points. The hypothesis is a prediction, if then. The if is the independent, the dependent is the result. So independent is what you do, dependent is what you get. If we're going to talk about variables and we're going to talk about independent and dependent variables, we must talk about confounding variables. They're also known as lurking variable, something that kind of sneaks around and sneaks up on you and ruins your research, or research bias, or just bias. Confounding variables are things that might affect the result or might affect the dependent variable that aren't the independent variable. Anything that could sneak up and kind of ruin your results that you didn't plan on or you didn't account for. And they come from what's called imperfect experimental control. Okay, let's quickly talk about experimental control, and we're going to fast forward a few units, or maybe rewind a couple months in your mind and talk about B.F. Skinner. B.F. Skinner had his operant conditioning chambers, and everyone calls them, of course, Skinner boxes. If you happen to have a rat and you had an operant conditioning chamber, you can control everything. You can control the time, You can control the humidity. You can control the temperature, when it eats, how much bedding or cedar chips it has. You can control every aspect of that rat's life. And if you have that kind of control, that's going to allow for something called causality. The problem we have is that humans don't live in an operant conditioning chamber. We live in real life with variables and unexpected things. So our lives, and if we had research participants, their lives are filled with confounding variables. So that would be a lack of experimental control. And if you look at this first graph, it's a nod to yesterday, meaning the more control you have, the less bias. And this is going to lead an experiment to this word we're going to talk a little bit about today called causality. If you can eliminate every other variable except the independent variable, and then if there's a change, we know the change was caused by the independent variable, not by anything else. And we're going to give a few examples. However, as complicated as that might be, we're going to add another layer onto it. There's a problem with too much control. People and animals don't act naturally in laboratory settings. Rats aren't evolved to live in little cages, and human beings don't live in labs. So the more control you have, the more Hawthorne effect you have. And you should remember again that the Hawthorne effect is the idea that people don't act naturally when they're being observed. Sometimes they're on their best behavior, sometimes they're scared, sometimes they're nervous. And so the more you control, the more they know they're being watched. The more they know they're being watched, then they're not acting naturally. And so the question is, are you getting the result that you want? As I said, lack of control prohibits causality with significance. Let's talk about that. We want an independent variable and only the independent variable to cause a change in the dependent variable. Um, if you have perfect control, the rat in the Skinner box, or nearly perfect control, as much as you can do, that might lead to what's called causality. And causality is the goal in science. One thing and the one thing alone, the independent variable, and it alone caused a change in the dependent variable. And that can only, this is important, that can only happen in an experiment. It can't happen in a correlational study. Go back and remember ice cream and drownings, okay? Let's go in a little bit more with confounding variables because it's a pretty important component to research design. And I'm hoping as I talk, you're formulating in your mind, you're seeing how these concepts relate to each other. They're woven into each other. It's not just a vocabulary word with a definition. Okay, placebos are fascinating stuff. The idea that if someone is so convinced that this fake sugar pill, this fake treatment can, oh, I don't know, reduce their fever or reduce their blood pressure, well, guess what? The mind is powerful enough to control the body. If you get embarrassed, if you think an embarrassing thought, blood flow changes and you might blush. So the mind is powerful. It's fascinating stuff. Now we get the idea of a placebo effect. In research, that's frustrating. Just as a placebo is fascinating, placebo effect is frustrating. It's bad for research because it's a confounding variable. Um, However, we got another kind of thing that's a related concept, a placebo treatment. That's necessary. Remember, if we give the independent variable to an experimental group, then we have to give a placebo to the other half, and we're going to call them control group. So the experimental group gets the independent variable, and the control group gets the placebo treatment. Okay, let's give an example. Let's talk about coffee. Most people believe coffee helps with something, whether it's paying attention or more alertness or waking them up or something. So if we're studying coffee's effect on paying attention, number one, we have to operationally define paying attention. But number two, our question is, how do we separate the biological effect of caffeine from people's belief about caffeine? Now, see, now we've got two processes. If I were to give a classroom full of students a bunch of coffee and I said, okay, we're going to see if this is going to wake you up. Well, a lot of students will say, of course it does. It's coffee. So we've interjected the independent variable of caffeine and people's belief about caffeine. So how do we, and here's the word, how do we control for that? Well, we give half of the participants, the control group, decaffeinated coffee. But we control for the decaf has the same temperature in the same cup, the same taste, the same amount of sugar, same amount of cream. It is perfectly the same as the independent variable. Our placebo is perfectly the same as our independent variable, except one thing, and that would just be the presence of caffeine. Now, this slide has a lot going on it, so we're going to kind of look at three common confounding variables that you can easily weave into an FRQ about experimental design. The first one is, again, the Hawthorne effect, which is very similar to demand characteristic. If you're being watched, you won't act naturally. If you have your driver's license and a police officer pulls up behind you, all of a sudden you have your hands on 10 and 2. You are on your best behavior. And I think every high school athlete will know when coach is watching, you are demonstrating your best. Demand characteristic is similar. And that means in an experiment where they might be measuring, oh, how kind of a person you are, well, you're going to act more kind because that's what you think you should do. Well, to combat the Hawthorne effect, we're going to use a single blind technique. Single blind means we must deceive the participant or participants about something. And so we don't let them know which group they're in. The control group which gets the placebo, or the independent group which gets the treatment or the independent variable. I'm sorry, the experimental group which gets the independent variable. Or they don't know the hypothesis. We try to keep the participant as for lack of a better word, as ignorant as possible. However, deception is an ethical problem, and we're going to talk about that at the end of today's presentation. We want to treat people with respect. We don't want to deceive them or lie to them, especially if they're volunteering. They're giving us their trust and their time. We want to treat them right. But if we tell them too much, they won't act naturally. Experimenter bias. Remember, researchers and scientists and experimenters are humans. They're going to make mistakes. And unfortunately, some of them might even make a conscious, purposeful mistake because they really want to prove their result. So how do we combat that? We use a double blind technique. Go back to our coffee example. What we could do is have, let's say, 30 students in a high school classroom, and we give them all coffee. What the researcher might do is have a teammate or research assistant. And the research assistant is going to keep track of who got the coffee and who got the decaf. The experimenter doesn't know. So when they're watching for paying attention or eye contact or things like that, they won't know which ones to look for. That's the idea of double blind. And the other one is representation bias. Are the participants representative of the larger population? Do the demographics match? Imagine in a large high school or college, I want to do an experiment on whether coffee helps people pay attention. And I put a post out there and people volunteered. And amazingly, all 50 people who volunteered were all female. It's possible that that could happen because it's random. Well, in a co-ed school, that's not going to be representative. And so that might introduce another bias there. Okay, we threw out a lot of stuff with confounding variables. The last three are going to be the Hawthorne effect / demand characteristic, experimenter biased, and representative biased. And those are the ideas that we want to combat by using research techniques. Okay, so we're going quick because I have a lot of stuff packed in today. I don't want to go too quick, and I wish I could almost ask you all if you get this, but just the nature of where we are today. Okay, another situation or another two words that might get students confused, just like dependent variable and dependent variable. A lot of students, even when they think they have them, they get them flipped. So I urge you to do the practice and do more practice. Make sure you have a solid foundation before you tackle the FRQ, that's coming our way for the AP Psych exam. Practice, of course, makes perfect. For random sample and representative sample, let's compare them. Okay, a random sample is each person in the larger population, and the abbreviation there is a capital italicized N, has the same chance to be chosen to be in the sample. Okay, it's nearly impossible to do. So let me give you a few examples. If you are a junior or senior in high school, and you are going to do a research study and you need 50 people. Well, where are you going to get them from? Chances are you're going to ask your friends, or if you're going to post it online, by definition, that's going to be limited by your social media circle of friends. Okay, well, let's say, no. You're going to go ask teachers to distribute the survey in your, to get participants, ask their students. Well, you're going to ask the teachers that you know and you've had. Okay, even if you were to just randomly pass out invites to students in the hallway, well, you're gonna miss students who might be ill or chronically sick. So it's very difficult to get a true random sample. Okay. Representative sample is some portion of the demographic characteristics. So what we're the same portion. So what we're looking at is we want to make sure if your school is 50% female and 50% male, you want to make sure that your sample, your participants are 50% male and 50% female. And we'd want to look at the ideas if the average age of the United States population is 38 years old, does your research, does your participants, do they have that age group? And unfortunately, in a lot of psychological studies, it's not. The sample age, or the age of the sample group, is oftentimes 18 because it's college freshmen. Okay, I hope that made it a little bit clear. Random samples, even if you do it randomly, even if you miraculously got all of your students' ID numbers from your school's registrar, and you picked a random 50 out of them, so it's completely random. That doesn't mean it'll be representative. It could be miraculously got 50 people of all of a certain ethnicity or religious belief. So again, just because random doesn't mean representative. Now we want to look at random selection versus random assignment. We know what random selection, or what I call random sample, is. We just talked about it on the last slide. Each person in the larger population has the same chance of being invited and chosen into the sample, to be a research participant. Random assignment is once the participants are chosen. So let's say you get your group of 50 research participants, volunteers, they want to help you out. They want to be a part of it. It's exciting. Once you get your 50, how do you divide them into the experimental group or control group? And you want to find a random way to do it, whether it's just as simple as rolling a dice or using a computer number generator or something like that. And this helps reduce experimenter bias. And this is so experimenters don't what I call pick teams. For some reason, maybe they have a certain sense about certain of their participants, and we're going to put them in the experimental group because I sense they're going to make big changes. And you don't want that. You want to keep things as honest and fair as possible. Okay, so we quickly went through random assignment. Okay, representative, and we did a random sample, and we did representative sample. Those three things oftentimes get students confused. I urge you to, look at that through your resources, or perhaps when we're done to go back and rewatch that, because they do. The temptation, the confidence. Oh, I've got that. I understand that. But maybe you want to practice it with it. Maybe write out a sample FRQ with that idea, with those ideas. Okay. Moving on, we're on ethical issues in research. I think it's interesting to note that all experiments cause some anxiety and stress. Even if a person really volunteers and they want to be part of an experiment or even take a survey, well, it's taking time, and maybe they have to in their schedule and they don't want to be late and they have to rush. That is going to cause some anxiety and stress. But obviously, some have barely any stress or anxiety required. However, some studies need to cause anxiety. For instance, how would you study anxiety? How would you study stress without perhaps on some level having people think of a stressful event, thereby elevating their stress levels? An ethical question and philosophical question is the information worth the pain? Is the dependent variable, the result of your experiment, worth the pain or suffering of that you're going to ask your participants to go through? And who is benefiting? Who decides? Well, to combat experimenter bias, because experimenters are human. And by definition, they're going to think that any idea they come up with is worth doing. And so they might kind of jump the gun and say, let's do this without really, it's kind of like this. Many of us can't proofread and see our own mistakes, and researchers might not be able to see some ethical issues that their experiment might run into. So an institutional review board is what maybe hospitals, universities, pharmaceutical companies, they demand that a researcher propose their experiment and run their experiment. They write up a proposal and they run it through the institutional review board. The institutional review board, or the IRB, is going to come back and say, no, we need to change this, or no, you need to change this, or no, this might violate some guidelines. So that's one way we can check and make sure that we take care of our participants. Okay, placebo effect. I put this in here even though we talked about it a few slides back. And the placebo effect is all about this mind-body connection that is at the core of psychology. Again, if you think an embarrassing thought, your blood flow to your face is going to change and face will feel hot. If you think a nervous thought, maybe your stomach starts to contract and you have butterflies in your stomach. So your mind is very powerful. And with the mind body, the idea here is, do neurons create thoughts or do thoughts create neural activity? Okay, so I put that in there because I wanted to merge the placebo effect with ethics and research. And this too might be the second addenda, and the second thing I want you to add on to today's homework. How can we ethically study the placebo effect? Maybe you want to spend, 5 or 10 minutes and trying to write out a quick paragraph, because by definition, you're going to try to say this thing that you're going to convince someone of a lie. And is that something that we want to do if we are supposed to take care of our participants? And that's kind of the first rule of research: take care of our participants. So a lot of folks are fascinated by the power of the placebo effect, because if a sugar pill could reduce fever, well, then why don't we just sell everyone sugar pills? And therefore we'd have no side effects. But if you're a researcher, how do you study that without the kind of inborn harm in lying to your participants? Okay, ethical issues in research number 3. Let's look at just a few kind of vocabulary words or talking points that you could weave into an upcoming FRQ about ethics in research. As I hinted at before, the number one thing that a researcher has to do is take care of your participants. These are people who volunteered. And even though sometimes they might be getting paid, they're not employees. They're putting their trust in you. You know more about the situation than they do, and you have to take care of them. And that might mean, in the extreme, stopping the experiment. And yes, wasting your time and money because you really wanted this to work, but it's not good for the research participant. So that's what we call fiduciary responsibility. You have to take care of your participants. The second bullet point is informed consent. And this is probably the most important one you'd want to remember and weave into any FRQ that asks you about research ethics. Subjects must know what's being studied. Okay, and that includes minors, because oftentimes a child might not understand the information enough. Folks with diminished capacity, think of someone with Alzheimer's. We'd want to do an experiment on Alzheimer's, but are they able to comprehend the risks? So we want to tell them as much as we can. Okay, I have in all caps and I have it italicized. However, if a participant knows exactly what's being studied, well, you guessed it, that's the Hawthorne effect. So then you're introducing bias, and that's something to be avoided. So we want to use the single blind, but we ought to be mindful of informed consent. Debriefing happens after a research study, after an experiment, especially if deception was involved. And this is where the researcher must tell the participants everything and even offer counseling if there was stress involved. That is the researcher's kind of moral and legal obligation. Subjects must have the right to decline to participate at any time. And I think if you've taken a psychology class, you've been introduced to some of the historical psychology studies that were, ethically awful. They convinced the participants they couldn't. The participants felt like they were trapped in a bad situation. And so you want to give participants the right to stop or quit at any given time. Information about the subjects must be kept confidential. If you were going to do an experiment about something that society might consider, oh, I don't know, maybe embarrassing or sensitive, drug use, criminal behavior, well, if someone is going to trust you with that research and they're going to let you in, be a little bit vulnerable to you, you need to take care of them and keep that confidential. Okay, so we're checking for understanding at this moment, and the idea is we threw a lot at you with ethics. There are several ethical guidelines. Okay, the most important, the overarching one is, of course, take care of your participants. And how do you do that? You give them enough information so they can willingly agree, and we call that informed consent. So those are probably the two most important things. Take care of your participants by informed consent. But every single one of those principles of ethics is important for guiding experimental research. Okay, we're towards the end today, and we want to look at doing a little bit of practice. So what I want you to do, of course, is write an FRQ. Our old friend Mrs. Schmidlap is back at it again. She wants to do an experiment on whether watching educational YouTube videos will increase learning. Explain how the following terms apply to Mrs. Schmidlap's ideas for this research. Okay, so you're going to want to identify the independent variable, you're going to want to apply it, and you're going to want to offer a synonym or a different way to say it. You want to operationally define the dependent variable. You're going to offer or find at least one confounding variable. And again, deep enough to explain it so the reader knows that you know what you're talking about, and offer at least one ethical consideration. Remember that in FRQ, there's no penalty for overwriting. It might be worth your time to offer two confounding variables or two ethical considerations. So that's going to be your homework for tonight until we meet again tomorrow. But remember, it might be worth your time. Can you come up with your own scenario? I'm happy to talk about my old friend Mrs. Schmidlap all day long, but perhaps you can come up with your own FRQ, your own scenario, and identify your own independent and dependent variable. Okay. Thanks for watching. We hope you'll join us again. Be sure to complete the practice question that we just talked about, and we're going to review the answer in the next lesson.